Hi everyone, we're going to just sketch a graph of this polynomial f of x. And the first thing we're going to do is determine the degree. Since this is a polynomial, it's not in standard form, I'm just going to add up my multiplicities here. And that's going to be 1 plus 1 plus 1 is 3, which is an odd number. Also, my lead coefficient is positive. Now, my y-intercept is when x is 0. So we're going to go through here and put x is 0, and you'll get this. So that equals negative 10. All right, so 0, negative 10. And where your zeros are is when y is 0. So that this piece here would be negative 1, because negative 1 plus 1 is 0. This part would be negative 5, because negative 5 plus 5 is 0, and this part would be 2. So you have 3 zeros at negative 1, 0, negative 5, 0, and 2, 0. Now the maximum turning points is n minus 1. Well, our n is 3, so we have 3 minus 1 equals 2. And the last part is determine the intervals where f of x is negative and f of x is positive. We're going to do that after we graph. So let's go back to end behavior now and let's talk about that. Just remember that it's odd and our lead coefficient's positive. So we actually had our graph comparison is y equals x cubed. Our degree was 3 and our lead coefficient is positive. So we're looking at this little area right in here. All right, so, and it is cubed, so I'm going to just kind of sketch it very quickly. Something like that. What we really care about is our end behavior. So that's end behavior. So this means we're starting in quadrant 3 and ending in quadrant 1. Quadrant 1 is positive, positive, and quadrant 2 is negative, negative. So basically what this little piece in here means is as x from 0 gets larger and larger, so does my y values. So this piece right here is in quadrant 1. Now, for this piece here, as x from 0 gets smaller and smaller, so does my y. So it gets smaller and smaller, and this is supposed to be positive. So if you look at this, all this means is positive, positive, that means quadrant 1. Negative, negative, that means quadrant 3. So we're starting in quadrant 1, or 3, graphing left to right, and ending in quadrant 1 somewhere. So let's go ahead and plot everything. We have a y-intercept at negative 10. It's hard for me to put it there. I'm just going to put the negative 10 here because we're just sketching the graph. We have a 0 at negative 1. At, why did I put negative 1 there? All right. We have a 0 at negative 1, negative 5, 1, 2, 3, 4, 1, 2, 3, 4, 5. All right. And this one is at 2. Since all these multiplicities are 1, that means we can cross the graph. So basically, let's just get started. And you're going to go up in here. We're not going to deal with the min and maximums on this video. I have other videos for that. So just kind of estimate it. And we go here at negative 1, we can cross. So go down to the negative 10. And then come back up through 2. This was 2. And it can cross because it's an odd multiplicity and you go up. So there's your graph. All right. And the last thing we need to do is talk about our f of x. So this is y equals 0. And above this line, y is greater than 0. And below the line, y is less than 0. So that's y is just your f of x. So we want to know where f of x is greater than 0 and where f of x is less than 0, or negative. So where it's greater than 0 is right through here. We're reading it from left to right. -5 to 1. Where is it above this line? So that's from -5 to 1. And also from 2 to infinity. -5 to 1, 2 to infinity. Now where's the graph below the y equals 0? Well, it's going to be here. So that's negative infinity. So you start here. You're looking at your x values. Negative infinity to -5. And then here from -1 to 2. So this portion here. -1 to 2. And that's it. Thank you. Have a nice day. Bye-bye.